Flight 9 just happened, and Ship 36 is already rolling to the test pad. This isn't normal. SpaceX is moving at a pace that's breaking every rule in rocket science. Ship 35 tested just 5 days before launch. If Ship 36 follows that pattern, we're looking at Flight 10 in days, not months. But here's the problem. The 6-engine static fire has crushed SpaceX before, causing weeks of delays. One failure, and this record attempt dies. With 30 Raptor tests at McGregor this week alone, they're pushing harder than ever. Can they pull off the impossible? Let's dive right in. The speed that shocks everyone. Ship 36 wasn't supposed to be ready until August, maybe September. Yet here it is, rolling to the test pad just days after Flight 9. This breaks every timeline SpaceX has ever followed. Something massive is driving this insane pace. And it's not what you think. While we watched Flight 9's spectacular success, SpaceX was already moving mountains behind the scenes. Barrel sections streaming out of the Star Factory, not for assembly but for scrapping. Perfectly good stainless steel rings heading straight to the junkyard. Why destroy materials worth millions? Because they're not good enough anymore. The truth hits like a freight train. SpaceX isn't just launching rockets. They're racing against their own revolution. Block 3 Starship is coming, and it changes everything. But they need Flight 10's data to make it happen. Without that data, the entire Mars timeline collapses. The speed that shocks everyone. Ship 36 wasn't supposed to be ready until August, maybe September. Yet here it is, rolling to the test pad just days after Flight 9. This breaks every timeline SpaceX has ever followed. Something massive is driving this insane pace. And it's not what you think. While we watched Flight 9's spectacular success, SpaceX was already moving mountains behind the scenes. Barrel sections streaming out of the Star Factory, not for assembly but for scrapping. Perfectly good stainless steel rings heading straight to the junkyard. Why destroy materials worth millions? Because they're not good enough anymore. The truth hits like a freight train. SpaceX isn't just launching rockets. They're racing against their own revolution. Block 3 Starship is coming, and it changes everything. But they need Flight 10's data to make it happen. Without that data, the entire Mars timeline collapses. The foundation built on quicksand. Boca Chica soil fights back against every shovel, every foundation pile, every attempt to build something permanent. It's sandy, waterlogged, and utterly unstable. Yet SpaceX is attempting to construct the world's largest rocket factory on this swampy ground. The Gigabay project now runs 24/7, with floodlights turning night into day. Workers are literally racing against the ocean. Every tide brings more water. Every storm threatens to wash away months of work. The pile drivers hammer continuously, trying to reach bedrock that may not even exist. Foundation crews pump water out faster than it seeps back in. It's like building on the ocean floor while the tide comes in. This isn't just construction anymore. It's a desperate fight against nature itself. Why push so hard? Because the Gigabay isn't optional. Without it, SpaceX cannot build enough starships to reach Mars. The entire colonization dream depends on this one building, rising from the most unstable ground in Texas, the regulatory knife's edge. Washington, D.C. bureaucrats hold SpaceX's future in their hands. Flight 9's investigation remains open, with no clear timeline for closure. SpaceX needs either complete investigation closure or a safety determination. Without it, Ship 36 stays grounded, no matter how ready it becomes. The FAA investigators are asking hard questions. Ship 35 exploded during re-entry. The official cause, hardware malfunction on one of the Raptor engines. The same type of engine that just destroyed itself at McGregor. 8 corrective actions demanded. 8 changes that must be implemented before flight approval. Each change creates new risks, new potential failure points. But here's the cruel irony. SpaceX is spending millions preparing for a flight that may never get approval. Ship 36 sits fueled and ready, while lawyers and engineers argue over paperwork in air-conditioned offices. Time burns money. Every day of delay costs SpaceX roughly $2 million in operational expenses. The clock ticks toward bankruptcy or breakthrough. The secret modifications, Ship 36, looks identical to Ship 35 from the outside. Same height, same general shape, same thermal protection tiles covering every surface. But the devil lives in the details. The heat shield pattern around the nose cone follows a completely new arrangement, tiles positioned differently, gaps adjusted, materials potentially upgraded. These aren't cosmetic changes, they're life or death modifications. Why change a system that worked? Because worked is relative when your vehicle explodes during re-entry. Ship 35 provided brutal lessons about thermal protection. Every tile that failed, every gap that overheated, every weakness that led to destruction, all of it feeds into Ship 36's design. SpaceX is gambling everything on modifications based on data from a vehicle that didn't survive. It's like designing a better life jacket using footage from the Titanic. The thermal engineers know exactly where Ship 35 failed. They've redesigned those critical areas. But space doesn't forgive assumptions, and re-entry doesn't offer second chances. If they guessed wrong about the fixes, Ship 36 meets the same fiery fate as its predecessor. The booster. Nobody mentions Booster 16 sits in Gigabay 1, fully tested and completely ignored by most coverage. This super heavy booster passed its static fire flawlessly, all 33 Raptor engines firing in perfect harmony, but Booster 16 carries the weight of SpaceX's entire reusability concept. The Mechazilla arms have been upgraded since Flight 9 with better heat shielding and faster hydraulic response. Catching a falling skyscraper traveling at supersonic speeds, the most audacious engineering challenge ever attempted. Previous boosters landed in the ocean, safe but expensive to recover. Booster 16 must thread the needle, literally flying between two massive mechanical arms while traveling faster than the speed of sound. Miss by inches, 20 stories of metal and fuel slam into the launch tower, destroying years of construction and billions in investment. The margin for error measures in milliseconds. Computer systems must calculate trajectory, wind speed, and mechanical response faster than human thought. Success proves reusability works. Failure questions everything SpaceX has built toward Mars colonization. The Florida Gamble, 1,000 miles away, explosive charges detonate across Space Launch Complex 37. The old Delta IV infrastructure, decades of proven rocket technology, reduced to rubble in seconds. They're destroying working launch facilities to build something that's never been proven. The demolished mobile service tower once assembled reliable rockets that never fail the mission. Now it's scrap metal, cleared for Starship facilities that may never work as designed. This demolition represents more than construction progress. It's SpaceX burning bridges, committing everything to an unproven system. The East Coast launch capability depends entirely on proving Starship works reliably. Multiple launch sites enable multiple daily flights, a cadence required for Mars missions. But if Starship fails, SpaceX just destroyed perfectly functional infrastructure for nothing. The debris field in Florida becomes a monument to overconfidence. The data desperation. Every sensor on Ship 36 serves one purpose: collecting data that doesn't exist anywhere else. Block 3 Starship design depends on information only Flight 10 can provide. How does the heat shield perform with the new tile arrangement? Do the modified Raptor engines handle extended burns reliably? Can the updated flight computers manage re-entry without human intervention? These aren't academic questions, they're life or death engineering decisions that determine whether hundreds of future astronauts live or die. SpaceX engineers are designing Mars mission profiles using computer simulations. But simulations killed astronauts before, when reality didn't match the models. Only real flight data provides real answers. Only Ship 36 can deliver that data. Without Flight 10's results, Block 3 becomes educated guesswork. Mars missions become impossible gambles with human lives. The pressure builds with every passing day. Engineering teams work around the clock, knowing that millions of people's dreams rest on their calculations. The timeline that terrifies competitors. Flight 9 happened just days ago. Ship 36 already sits at the test pad. Traditional aerospace companies take years to achieve what SpaceX is attempting in weeks. Boeing's Starliner took over a decade to reach operational status. Blue Origin's New Shepard required years between significant milestones. Even SpaceX's own Falcon 9 development stretched across multiple years. But Starship operates on a different timeline entirely. Rapid iteration, aggressive testing, constant improvement. Success builds on success, failure teaches immediate lessons. This pace terrifies established aerospace companies. Their methodical approaches, their committee-driven decisions, their risk-averse cultures, all obsolete in the face of SpaceX's relentless advancement. China's space program, Russia's rocket industry, Europe's launch capabilities, all falling behind a company that treats rocket science like software development. But speed creates risks. Moving this fast means less time for testing, less margin for error, less certainty about outcomes. Ship 36 represents the ultimate test of this philosophy. Can SpaceX maintain quality while achieving impossible speed? The moment of truth approaches. Single-engine static fire, completed successfully. Ship 36's Raptor lit up without incident, proving basic functionality. Next comes the real test. 6 engines firing simultaneously. 6 separate systems that must work in perfect coordination. 6 potential failure points that could destroy months of preparation. Previous 6-engine tests revealed problems invisible during single-engine runs. Vibration harmonics that shake the vehicle apart. Fuel system interactions that cause engine shutdowns. Computer glitches that trigger automatic aborts. Any one of these issues delays Flight 10 by weeks. Multiple problems could push the launch into August, exactly the timeline Ship 36 was supposed to follow originally. But if everything works perfectly, Flight 10 happens within days, not weeks. The fastest Starship turnaround in history becomes reality. SpaceX teams monitor every sensor, every data point, every minor fluctuation that might indicate trouble. The test happens in broad daylight, with cameras capturing every millisecond of the burn. Success or failure reveals itself in seconds, but the consequences echo for months. The entire space industry watches Ship 36's engines. Competitors hope for failure, fans pray for success. Engineers simply want data, regardless of the outcome. In the end, physics decides everything. No amount of hope, fear, or corporate pressure changes the fundamental laws that govern rocket engines. Ship 36 either works or it doesn't. The question that changes everything. So here we are. Ship 36 sits at the test pad, engines ready to fire. The fastest Starship turnaround in history, happening right now. But this isn't just about breaking records anymore. It's about proving whether humanity can actually reach Mars in our lifetime. SpaceX is betting everything on a philosophy that traditional aerospace calls impossible. Move fast, test often, learn from failures. Ship 36 becomes the ultimate test of that approach. If they succeed, we're witnessing the birth of true space transportation, daily flights to orbit, routine missions to the moon, and yes, eventual colonies on Mars. If they fail, well, that teaches us something too. The next few days will reshape space exploration forever. Either SpaceX proves that rapid reusability works, or they learn why everyone else takes years between flights. What's your prediction? Will Ship 36 fly within the week, or are we looking at delays that push Flight 10 into July? More importantly, if SpaceX pulls this off, what does it mean for every other space company trying to compete? Drop your thoughts below, and if you want to catch Flight 10 the moment it happens, hit that notification bell. Because when history moves this fast, you don't want to miss a second of it. The future of space exploration, decided in the next 72 hours. The ISS is cracking apart right now. Metal fatigue is destroying the Russian modules and air is leaking out daily. Elon Musk just shocked everyone. He wants to destroy the entire station within 2 years. This is the same guy making billions from ISS missions. Why would he kill his own cash cow? Because SpaceX secretly upgraded Dragon for an impossible mission. Drag the $150 billion ISS into controlled destruction. But here's what nobody's asking. What happens to 30 years of experiments? Can Dragon actually pull this off? And what's Musk really planning next? Let's dive right in. The crisis nobody saw coming. Here's the truth NASA doesn't want you to know. The ISS has been bleeding oxygen into space since 2019, and they've been covering it up. It started quietly, just a few pounds of air escaping each day from the Russian section. Engineers called it normal wear and tear. But normal doesn't kill astronauts. The leak is in something called the PRK transfer tunnel. This connects Russia's Zvezda module to a critical docking port. Zvezda launched in 1998. It's been up there for 26 years, and that's where our nightmare begins. But why is this tunnel failing now? The answer will shock you. Metal death in slow motion. Every